What's going on, gals and guys, and welcome back to another video with me, Ben Rogajan, aka the Seattle Data Guy. Today, we're going to be reviewing another creator's perspective on why they think data engineering is blowing up right now. Now, the interesting thing here is, well, they are not a data engineer themselves, but instead a data scientist. They are none other than the one, the only, the Ken G. The question is, can a data scientist have an accurate view on kind of what data engineers do and maybe why data engineering is becoming so popular recently? Let's dive into Ken G's video and figure out if we can answer that question. Let's just start from the beginning.
When I was doing research for my last video, I came across a really interesting finding. Data engineering is now growing faster than data science. I got to thinking, what does this mean for the data domain as a whole? Is it a good thing? And why is this happening now?
Data engineering.
So hot right now.
For the most part,
I've definitely seen a similar trend for the last couple of years in the whole data space. I've even seen companies like Google, which didn't really have, I think, a traditional data engineering role for a while there, start recently hiring data engineers, which I think is very interesting. I think a lot more companies, even companies like Airbnb, which I've discussed this in my review of their data engineering strategy, which was a video I did a while back, recently realized that they shouldn't just have software engineers and data scientists do their kind of data pipelines, but instead they also need someone to kind of lay that foundation in terms of like core data infrastructure. Part of this is just because, again, software engineers and data scientists have other focuses and they need to be doing other things, and they might not be specialized in building data pipelines. So I think that's really why we're starting to see companies of all sizes really start fighting for more data engineers.
Data engineering is upstream from data science. The work that they do building data warehouses and data pipelines allows data analysts, data scientists, and machine learning engineers to build models and create insights from data. Why is this domain that should...
Okay, I just have to pause it for a second there because this dough pun is a little ridiculous. I kind of get it, right? Domain, ha ha ha. He's making pizza. So just a quick pause.
Should precede data science, growing in popularity after data science did. For better or for worse, the world doesn't always work linearly. Data science became sexy because many of the top technology companies were making gobs of money with it.
It's like everywhere I look, money, money, money. Even 10% of this would be quite a windfall.
Non-tech companies saw the value that data science and machine learning were providing, and they soon followed suit. Unfortunately for many of these companies following the trend, they didn't have the data infrastructure to properly leverage data scientists. Many of the data science roles that they were hiring for, they ended up doing data engineering work that they weren't necessarily specialized.
Yeah, I'm pretty sure Ken G has this right. You know, they were kind of seeing the end result of what these big tech companies were doing, and they were like, oh wow, so this is what we need to be doing, right? But essentially this is kind of like looking at like Michael Jordan and being like, wow, he just, led the Bulls to all of these different championships. We just have to be Michael Jordan and we will be successful, right? Like that was kind of the mentality here. But what they didn't realize is these companies, especially these large tech companies, whether it's a FANG or some of the other similar companies like Spotify, they spent a lot of time, money, and resources investing into a robust data infrastructure, whether it be things like data pipelines or data storage, in order to manage all of the actual data that then they could use to do all their machine learning and data science work. So it wasn't like they just had all of this data infrastructure ready to go. They spent a lot of time building it all, because at the end of the day, a lot of these companies were focused on data. How they made money, how they kind of drove their profits and increased user retention was through data. They didn't just use data as kind of like an afterthought. It was their focus. And I think what has happened in a lot of other companies is data engineering, data management, and all these other things have been treated as a cost. So what companies usually do in that case is they try to reduce those costs as far down as they can. Let's see where Ken G takes this.
They were hiring for, they ended up doing data engineering work that they weren't necessarily specialized for. I personally think that this mistake cost these companies millions, possibly billions of dollars.
Yeah, I think I could agree with that statement. I think the fact that companies have put so much investment into data science and used a lot of this talent in the wrong ways probably has cost companies millions of dollars. Again, maybe billions, but at the very least millions.
Also led to a lot of confusion in the market about what a data scientist does. And this is a topic for an entirely different video because it is so large. What the top technology companies neglected to mention when they were describing the success of their machine learning models was that they'd already built the infrastructure to support data science. They've had data engineers or similar roles on staff for years, sometimes even since the start of the company, making sure that...
What did I say? Like I said, these companies had data infrastructure from day one. Again, you look at Google, Facebook, Amazon, they all developed some form of data management infrastructure. Amazon developed Redshift, Google developed BigQuery, Facebook had like Hive and Presto and a couple other iterations as well. These companies were literally developing their own data infrastructure because they realized how important it was not just to have performant data, but also manage it well. So data really is the lifeblood for these companies. That is what they do at the end of the day.
The company, making sure that the data could be leveraged by sophisticated tools. Again, it wasn't that the top technology companies just hired these roles earlier. They also built their businesses with data and scalability in mind. They spent a lot of time up front thinking about how to store their data and make it useful to them in the long run. This is a pretty common theme with a lot of these big technology companies in general. They build systems to work for them in their specific business setting. For example, Facebook, Google, Microsoft, and quite a few other of these behemoths, they have their own suites of machine learning tools that are used internally. You think that they don't also have unique approaches to managing the huge volumes of data that they collect?
Whoops, I guess I kind of spoiled his punchline, but yeah, like I said, they've all developed their own internal tools to manage a lot of this data to begin with.
For most of these technology companies, their businesses just simply wouldn't work if they couldn't monitor their data consistently. So they obviously had to build out this infrastructure. So these big tech companies, they either hired data engineers early or they started with them. What about the other companies? I believe that the massive uptick in data engineering's popularity comes from many less technical companies realizing they made a massive mistake. They needed to hire people to fix their data before hiring all these data scientists. And unlike cutting-edge tech companies and startups, most other companies were not explicitly designed to scale. They need a tremendous amount of help to upgrade their data infrastructure and to make it usable for analysis, machine learning, and eventually AI. As you can imagine, this is not a small task. The boom for data engineering,
as he said, this is not a small task. Companies are spending anywhere from hundreds of thousands to millions of dollars, on the implementation side, as well as then, paying cloud services like BigQuery, Redshift, and all of these other toolings in order to store all of that data effectively. The one benefit of kind of the world we live in today is companies of varying sizes can take advantage of a lot of these solutions. So if you do have big data or need better data management practices, there are a lot of tools that you can use out there that are great.
The boom for data engineering is a correction for the companies that jumped straight into the data science bandwagon before realizing they weren't ready for it.
If that was a test, that wasn't fair because I wasn't ready.
If you're interested in if your company is ready for data science,
I'm gonna have to steal his method of referencing other pieces of content. I kind of like the whole taking a moment to have a quick reference to another video or piece of content. So I might start using that here in the future.
I have a hopefully helpful video pinned in the top right corner about the data science maturity process of organizations. So is this a good thing, a bad thing, or somewhere in between? I personally think that this is great for the future of data science and AI. Companies with better data can build clear infrastructure focused on building useful models, rather than ad hoc tasks. In my mind, this could be the springboard for a true data science or AI revolution.
I just realized he's been kind of doing this whole pizza thing throughout the whole video, so maybe this was kind of an ongoing joke that he had about the whole domain thing. So don't know why it took me so long to click with that.
Should help build more clarity around roles in the field. Data scientist has been the blanket term for a lot of roles in the space, and a clear separation between what they do and what data engineers do clears up a lot of ambiguity for companies as well as job hunters. Most of all, this signals to me that data science is going to go viral in the foreseeable future. Again, if companies are investing this heavily in the pipeline upstream from data scientists, how big is the demand for data scientists, machine learning engineers, and AI researchers going to be when they finally get the existing data infrastructure into a good spot? To be clear, for
the hard thing here for getting data into a good spot is that we're always trying to get it in a better spot, or it's always kind of going from a good spot to a worse spot to back to a good spot. That is to say, every time we have to do a migration on the data engineering side to a new data storage system, or maybe an ETL system, or just getting a new source system, right? Like every time a company changes from using Workday to Greenhouse to some other system, that forces data engineering to come back into play, reset up everything that they've done, and maybe even rebuild a lot of their KPIs. And so that's something that I think a lot of tooling is trying to fix here in the future. We'll see if it can do it. This is something that we've been through over and over again, right? Low code solutions try to come in, fix a lot of the problems that we have as data engineers, which is all of this repetitive work that we do. So I do hope for a future where as data engineers, we have a lot more automated processes. We don't have to spend a ton of time recreating the same data connectors over and over again, but instead we can kind of just press a button and, process a lot of the initial data automatically without having to do too much business logic. This might be a while because the more companies want to do custom work and customize their Salesforce instance, the more complex it makes our work as data engineers because we have to spend a ton of time trying to manage all of that. So this is kind of a fine balance, and we'll see what happens in the future. I think the only option is to try to figure out how we can create better tools that will just automate a lot of this repetitive work. Because in the future, we're just going to keep having more and more data sources, which a small team of data engineers just won't be able to handle. So we need better tooling in order to get to that point, right? Like we're never going to be able to manage all of the different data sources by creating a ton of custom code. It's just going to be too much. So I'm curious to see what happens in the future. If we can start figuring out how to implement better solutions and implementing them better, we might have a chance. But otherwise, we're going to keep kind of playing this game where we go back and forth, where we switch systems constantly and are constantly, in turn, never really taking any steps forward, but always kind of going forward and back. So we'll see on that one.
To be clear, for a lot of companies, data engineers aren't an entirely new role. They've been called data architects, ETL developers, database developers, or even SQL developers. So why is all this popularity happening now specifically? Honestly, these are all just guesses, but there have been a few forces that I think are fairly relevant. The first I've covered in depth in this video so far, and that's the fact that data science has taken off so much. It has now been enough time that many companies have full data science teams built out. Companies have also had enough time to realize that these teams aren't driving as much value as expected because they're lacking quality data.
I shall need more data for my estimate.
Second,
I don't think it's just about quality data in terms of why data science isn't driving enough value. I've worked at companies where I've tried to take on a junior data scientist role. And what I found was there wasn't a good framework for teaching junior data scientists what to do or how to even drive value. It's never clear for a junior or even a mid-level data scientist at some companies what businesses need. And that lack of a framework, I think, is what causes a lot of value to be lost. Yes, you could argue that data engineering needs to be improved and, data models and data warehouses, but data warehousing and all of this has been around for a while. I think data science still has a lot of growth in terms of creating solid processes that when you get a new data scientist in, you teach them this is how we actually go from, a concept and, some sort of business question and create value from that. I don't think a lot of companies have that. I think a lot of companies shift their data scientists so often that a lot of best practices don't get created. So I think this is where the drop off tends to be, is this kind of ambiguity that's just too ambiguous, right? Yes, as employees, we should be able to deal with some level of ambiguity, but the truth is there's just a lack of clarity, I think, for a lot of roles, especially in data science. And that makes it very difficult to be effective if you're a data scientist, right? How can you be effective if you don't know what that means? So I think that's one of the biggest gaps. Quality data, I think, is sure an issue, and maybe the amount of data, making sure you get enough data to these data scientists at the right time. Yes, that's always a need. We're always kind of backed up as data engineers because there's so many different requests that we have to answer, whether that's answering questions for the business, whether that's, developing data sets for more analyst types or PMs or for data scientists. We're always kind of busy, but I don't think that's the only reason. I think, again, another gap is just, again, a lack of process for most data scientists.
Snowflake and a couple other massive companies have gone public with clearly focused products on data. Other companies are realizing how much the market is valuing data-related projects, and they're taking action based on that. It's a little bit hard not to be kind of self-serving with this last one, but I think the data communities these days are doing a great job highlighting the importance of quality data. I've seen great posts on LinkedIn talking about this. I've seen informational videos and articles.
So again, I'm going to kind of take a moment here and just say the concept of quality data has been around for a long time. I used to be involved heavily with Dama, which does data management. That's kind of their focus. They put out a book. They partner with a group that puts out a book about, good best practices for data management. And part of the pillars of that whole concept is data quality. So data quality is not new. The concept of good quality data has always been there. It's always an easy out, both for analysts and data engineers, right? We sometimes call out the same stuff because we might only be given terrible data. And so we always use the term, right? Garbage in, garbage out. And that term has been around for at least a decade from when, I started working, but probably even longer. So yes, quality data is an issue, but it's always been an issue and it always will be an issue. It's not something that will get fixed. It's going to keep growing, and there's tools we can put around in place to help improve the situation, but I don't think that data quality is the only problem. I think back in 2017, I wrote an article about, data quality and the importance of it and how it's like unsexy. To counter the whole sexiest job in the world being data science at the time, I wrote this article. So this is somewhere I'm going to disagree a little bit with Ken just because it's been around so long. The data quality problem has been around since day one. You know, we joke about the whole data syncing issue, which is another kind of data quality problem. For anyone who doesn't know what that is, it's often you have report A, report B, and they should be saying the same thing, but they don't because one report comes from a data source that's slightly different than this one. And that is a whole different data quality issue that could be related to timeliness of data. So data quality issues will continue to be a problem. So we're just going to keep running into more of these problems because data is becoming more complex and harder to prove, you know, when it's accurate. So maybe this isn't so much a disagreement, just a clarification that data quality issues have been around for a long time and they're going to continue for a long time because the more data we try to process, the harder it is to kind of just manage it all and grasp it all.
And articles, some of which I've linked below. And I've also had quite a few guests on my podcast discussing these things. I think that the pandemic has encouraged people to be more vocal on platforms like LinkedIn, and this has really helped to spread sentiment and awareness around the importance of data quality. Since I've been talking about the value of data engineering so much in this video, a natural question.
Since I just saw the title of that video kind of pop up there, it was like how data science has changed in the last 20 years. Maybe he did do a little bit more of a background on data quality. So maybe check out that video and see what he says there. Just to maybe even correct myself.
A natural question might come up. Should you become a data engineer? Should you even consider this over a career in data science? Honestly, this all really depends on you and your interests and aptitudes. First, you should explore the various data roles in the data domain and the differences between them. I have a video pinned above that should give you just a little additional information on all the different tracks. Right now, I think it would be a little easier to land a data engineer compared to a data science role just because of the demand, and you don't necessarily need quite as much education in most cases to land this data engineering role. If you feel like you'd enjoy it, then by all means go for it. From my perspective, most data engineering roles have just a bit more structure and clearer expectations than other.
Yeah, I totally agree that data engineering definitely has a clear kind of scope of work. Most of the time, sometimes that kind of grows. Sometimes we do have to do more data science-y or maybe even machine learning engineering stuff now in the modern kind of world where maybe you only have one or two technical people, so we take on a lot more. But at a larger company, your role is pretty well defined on what you're going to be doing most of the time. Obviously, that's not every case, but I think in a lot of cases, you're going to be doing pretty straightforward work. And I actually covered that in a recent video that I made that I'll link above. That was, you know, why you should become a data engineer and not a data scientist.
Again, if this is for you, makes a ton of sense. Data engineering still has many of the analytical components, but as the name suggests, it does have more similarities to software engineering than data analysis or data science do some of the time. Still, going from data engineer to data scientist is definitely doable if you find that you prefer the model building and the exploratory stuff. I've linked an awesome video in the description from my friend Sundas on her journey going from a data engineer to data scientist. Clearly, I'm not.
Oh no, we were betrayed. Someone went from data engineer to data scientist. Usually goes the other way around, honestly, or at least maybe not all the time, but that's what I've seen a lot of people do is data scientist to data engineer.
Clearly, I'm not a data engineer, so take my thoughts here with a grain of salt. And for those that are interested in learning more about this profession, I've linked a video from an actual data engineer, the Seattle data guy.
Aw, he mentioned me. That's so sweet.
About how to break into data engineering. I hope this video helped you to better understand the data landscape, especially as it relates to data engineering. If you enjoyed the video, please select that like button, click subscribe, and turn on notifications to trigger an alert when I post my next video. It's a little data engineering humor for you there. Until next time.
Ha ha ha. Yeah, he just referenced like select and trigger, and I missed the middle phrase, but yeah, select. Obviously, select all, and then trigger. If you've ever built a trigger in a database, you kind of should know what that is. All right, so that was me reviewing Kenji's video on data engineers. I honestly think overall he's got it pretty much right. I think, again, data quality is kind of an interesting thing where every couple of years we talk about it again, and we're never really going to have perfect data. And it's really easy to always kind of point fingers at the data for not being perfect quality. But oftentimes it's whatever the source kind of gives us. Speaking of liking, subscribing, and clicking that notification bell, if you enjoyed this video, take a moment to maybe do the same thing here. Thanks so much for all of your time, guys, and I will see you guys next time, and goodbye.